Alright guys, so this is going to be your answer key for your classwork for multiplying monomials. I'm going to go through and type out the answers for you, and then again, if you didn't do as well on your classwork that you'd like, you can watch this video and fix the answers where you need to fix them. So the biggest thing to remember first is you want to try and use the equation button. So the equation button allows you to type those exponents nicely. So you put it down like you would have wrote normal text box, and then you just start typing. So remember, with our coefficients, we are multiplying them. So coefficients are going to be those whole numbers in front of the variable, so like the 9 and the 9. So again, because this is a multiplication problem, we are multiplying the coefficients. So this would become 81. After you multiply your coefficients, then you take a look at what bases you have. So I have two different bases. I have the z's and I have the y's. So we'll start with the z's. So you keep your base, which is z. And then remember, you can only add together the exponents that have the same base. So if we look at the two z's, both of those z's have a 3, so this would become z to the 6, so if we add the two 3's together. And our last base is the y. Notice that there's no other y's in the problem, so I just keep the exponent of 5. And a reminder, in order to type those exponents, all I did was do the shift and 6, and it allowed it to rise above your base. So that will be my answer for number 1. If I take a look at number 2, there's only one coefficient, so that we're going to keep it as 4. There's nothing to multiply it with. I only have one base, which is x, and when I add those two exponents together, the 2 and the 3, it becomes x to the 5th. So a lot of us did that one really well, so I'm not going to spend time on it. But again, the idea is to multiply coefficients if you have them, keep the base, add the exponents. So if I take a look at number 3, just like number 2, there's only one coefficient, so I'm going to keep that, which is 5. And now I have two different sets of bases. So I have y's and I have z's. So I'll go with the first one I see, which is a y. Notice that there's only a 3 on this y and there's nothing on this y. So a lot of comments I put on your post is if you don't see an exponent, so in this case y doesn't have an exponent, we know that there's an exponent of 1 right here. So if it helps, maybe to write this down on a separate piece of paper and write the 1 in, and to see the 1 here. But you want to make sure you add that with the 3. So instead of being to the 3rd, this is actually going to be y to the 4th by adding the 1 and adding the 3. And then our next base is the z. So the z's are kind of straightforward. You keep the z and add the 3 and the 5. So that would be to the 8th power. But again, a lot of you had y to the 3rd, and that's just because you forgot that there was a 1 on this y. If I take a look at 4 doesn't have any coefficients, so it's a lot like the last classwork we did. Keep the base, add the exponents, the 2 plus 2 gives us the 4. Alright, so if I take a look at 5, again, there's no coefficients, but we do have two different sets of bases. So I'll start with the first one I see, which is z. The other z has a 2, and this one has a 2. So when I add those together, it's z to the 4th. And there's only one y, so I just keep the exponent and the base. Again, the y z to the 4th came from adding the 2 plus 2. Alright, so for number 6, we do have two different coefficients. So we have 6 and 7. So remember, we do multiply coefficients. So that would become 42 when we do 6 times 7. Then the next base that I see is a y. Again, this y does not have an exponent, and this y does not have an exponent, but we know that the exponent is 1. So if I add the 1 plus 1, that does become y squared. So you don't want to just keep it as a y, because if we have two of them, they both have an exponent of 1, and we add those together. And then our next base is x, and that has a 4 and a 5, so that does become 9 when I add them together. So again, if I commented on your post that the both y's have a 1, that's what I mean, that you have to actually add those y's together and become y squared. Alright, so same kind of thing happens with number 7. Number 7, we have 5 and 9 are our coefficients, so we multiply them together to get 45. And again, I'm not just going to put y here because it's not these, because they have nothing here. I know both of these have an exponent of 1, so when I add them together, it does become 2. So that's probably the biggest mistake I saw in a lot of your papers, so you do have the opportunity to go ahead and fix that if you got it wrong. So number 8, we have 6 and 6. So 6 times 6 is 36 because those are our coefficients. I keep the x as my base, and remember, on this x there is a 1. So when I add the 1 and the 5, it becomes x to the 6. So hopefully that's starting to make a little bit of sense. A lot of times when you write these out, I know we can't write them out if you're using Cami, but if you want to write them on a separate piece of paper, it is helpful when you don't see an exponent just to put the 1 there to remind yourself. All right, so number 9, we're going to multiply the 3 times 4 and get 12. The next base I see is a y. Again, there's nothing on this y, so I would have written in a 1 here. And then if I add the 1 plus 2, this does become y to the 3rd. And then there's only one z, so I keep that base, and there's nothing to add it with, so I keep the exponent. All right, so we're halfway done here. If I take a look at number 10, again, 10 is pretty self-explanatory. It kind of goes from the last classwork. I keep the y, and if I do 2 plus 3, I get 5. So 11, now we have 2 coefficients, so the 8 times 9 would become 72. Then I see my base, which is y. There's 2 y's with a 2 and a 4, so when I add those together, it becomes 6. And then I keep my x, add the 5 and the 5 to the 10. So again, the big idea is we multiply coefficients, we add exponents with the same base. So if I take a look at number 12, no coefficients. I did see a lot of you enter x to the 3rd. This is incorrect because again, there is a 1 on that x, so this would become x to the 4th because we're adding 1 plus 3. So anytime, again, you don't see an exponent, that exponent is 1. So if I take a look at 13, my 2 coefficients are 2 and 9. 2 times 9 becomes 18. I keep my base of y. Again, neither of these have an exponent, so I know those exponents are 1. So when I add the 2 ones together, it becomes y squared. And then again, this z doesn't have an exponent here, so this exponent on the z is 1. So if I add 1 plus 5, it does become to the 6th. So if you look, a lot of your answers might be one smaller exponent than mine, and it's just because you forgot that there was 1s on all of these bases. So if I take a look at 14, 7 is my coefficient, so there's nothing to multiply it with, so I keep it as 7. And then I have bases of x. This x doesn't have anything, so it's a 1, so I do 1 plus 4, and it's to the 5th power. So if I take a look at 15, same kind of idea. There's nothing to multiply 2 with, so I keep it. My first base that I see is z. If I add the 2 exponents on the z's, I get 2 plus 2, which is 4. And then if my next base is an x, the 2 exponents are 3 and 5, so that does become to the 8th power. Some of you on your paper, which I didn't mark this wrong, might have had it like this. You might have had it as 2x to the 8th, z to the 4th. So in that case, they're actually the same thing. You can switch around your bases as long as you don't switch around what has the exponent. So notice both of these x's still have an 8, both of these z's still have a 4. So either way you wrote it, it is correct. Last row here, we have y x cubed times y. So there's no coefficient, so I go right to my base. And again, at this point, we should be getting the idea that both of these y's have a 1. So if I add them together, it does become squared. Nothing to add the x cubed with, so I keep it the way it is. 17, we do have a coefficient, but there's nothing to multiply it with, so we keep the 4. And then my base is z. We add the 1 and the 2, and that does become to the 3rd power. So last one here, no coefficients, so I'll start with my base, which is y. Again, nothing on this y, so I should have written in a 1 here. So the 1 plus 4 becomes 5. And then my x is going to be to the 4th power because there's nothing to add it to. So again, this is going to be your answer key here. I will post this without the video, but again, it is a good idea to understand how to do this because we will have more assignments that relate to this. Because they, as you saw from the last one, they do get a little bit harder each time. So you want to make sure you understand these before you move on. And a big idea is that we're multiplying coefficients. So like 9 times 9 is 81. And then we add our exponents on similar bases. And if something doesn't have an exponent, then that exponent is 1. So feel free to email me if you have any questions.